Hi everyone, this is your math guru. In this video, I'm going to show you how to convert the following recurring decimals to fractions. In the first example, I'm to change 0,8, that's recurring, into a fraction. A quick recap, if I have a decimal, a normal decimal that is not recurring, like 0,4, and I'm to change into a fraction, all I need to do is to move my decimal point to make it a whole number. In this case, I have one digit after the decimal point, so therefore I'm going to move my decimal point one space to the right. That will give me 4 whole number divided by, because I moved once, that's divided by 10 with 1 0. Another example, if I have 0,14, because I have two digits after my decimal, what that means is I'm going to move twice to the right, and writing that in fraction, I have 14, that's the whole number, divided by, I move two spaces, that will be 100. But in the case of a recurring decimal, if I'm to rewrite the recurring decimal, 0,8 with a dot at the top will be equal to 0,88, and that goes on. So what this means is I can't use the conventional way of converting into a fraction. So what I would do is let x equals my recurring number, that's 0,888, and so on. I'm going to tag that my first equation. The next step is to multiply both sides by 10. So if I multiply both sides by 10, on my left hand side 10 times x, that's going to be 10x. And on my right hand side, if I multiply that by 10, that means I'm moving my decimal point one space to the right. That becomes 8,88, and then that goes on. So that will be my second equation. So therefore, I'm going to subtract equation 1 from 2. So I have equation 2 minus equation 1. So on my left hand side, I have 10x minus x equals, on my right hand side, I have 8,888 and so on, minus 0,888, that goes on. The aim is to have the same set of digits after the decimal point, such that if I subtract 10x minus x, that's going to be 9x, equals, if I subtract, that will be 8 minus 0, which is 8. Therefore, to solve for x, I divide both sides by 9, and whatever you do on your left, you do on your right, 991. Therefore, my x, which is the recurring number, will be 8 divided by 9 in fraction. Let's look at this next example. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In the second example, I'm to convert 0,47 with the recurring dots on 7 to fraction. So like I did earlier, if I rewrite that, I have 0,47 with the recurring dot. That's equal to 0,477. The 7 goes on. Therefore, I'm going to say let my x equal to my recurring number 0,4777. Now, the aim, like I explained in the last example, is to have the same set of numbers after my decimal. So the first step is I'm going to multiply what I have by 10. So if I multiply that by 10, what I'm going to have is 10 times x, 10x, equals, I'm going to do the same thing on my right hand side, and then I have 4,777 and so on. I'm going to tag that my first equation, equation 1, and then I'm going to multiply the first equation, x equals 0,4777, that's the recurring number, I'm going to multiply that by 100. So the second step is to multiply by 100, multiply by 100. And if I multiply that by 100, I'm going to have on my left hand side 100 times x, that's 100x, equals on the right hand side 0,477 by 100, that is 47,777, that's recurring. That will be my second equation. So therefore, if I subtract equation 1 from 2, so I have equation 2 minus equation 1. On the left hand side, I'm going to have 100x minus 10x. And on the right hand side, I have 47,77, that goes on, minus 4,777, that goes on. Note that the reason why I multiplied by a 10 and a 100 is I want to have the same set of digits after my decimal point, so that cancels out, and then I'm left with 100 minus 10, that's 90x. And on my right hand side, I have 47 minus 4, that will give me 43. Therefore, dividing both sides by 90, I have my x equals 47 or 43 divided by 90. This cancels, 90 and 90, that's 1. So changing 0,47 recurring decimal into a fraction will be 43 over 90. You can pause the video and try out the third example, 0.681. Change that to fraction, and let's see what you have. So if I take you through, I have my 0,681, the recurring dot on 8 and 1. So that means 8 and 1 are recurring. That's equal to 0,681, 81, 81, and so on. So the first step is to say, let my x equals my recurring number, 0,681, 8181, that goes on. I tag that as my first equation, but before I tag that, I'm going to do my multiplication first. Note that I need to make the numbers after my decimal the same. So the first step is to multiply by a 10. So if I multiply by a 10, my expression becomes 10x equals, on my right hand side, I have 6,818181, that goes on, and I'm going to tag that my first equation. The second step is to multiply the same expression by 100. Now note that if I multiply by 100, if I move my decimal point 1 and 2, it's going to stop in between 8 and 1. That means I'm not going to have the same set of digits after my decimal. So therefore, I'm going to multiply that by 1,000 instead of 100. So therefore, my equation becomes 1,000x equals 681, 8181, and so on. That's my second equation. And you can see that now I have the same set of digits after my decimal as shown. So therefore, I'm going to subtract equation 1 from 2. So I have equation 2 minus equation 1. And what that gives us is, on my left hand side, 1,000x minus 10x equals 681, 8181 minus 6,8181. That goes on. On my left hand side, I have 990x equals the h1 after the decimal cancels off, that's 0. So I have 681 minus 6, that's 675. And dividing both sides by 990. Whatever you do on your left, you do on your right. I have that cancelled. I have x equals 675 divided by 990. I can simplify further, and that will give me 15 divided by 22. So changing 0,681, the recurring decimal to fraction, I have that as 15 divided by 22. Thanks for watching. Bye.